At dawn on the San Francisco headlands, the fog comes in low and salt-heavy off the Pacific, and the coast feels ancient, undisturbed. Brown pelicans ride the thermals above the water. The kelp canopy should be swaying just beneath the surface here. It isn't. 30 years ago, if you had slipped beneath the surface anywhere along this stretch of the Northern California coast, the water above you would have looked like a cathedral. Bull kelp rising 40, 50 feet from the seafloor, the blades catching the light and breaking it into shifting green columns. Rockfish holding in the shadows between the stipes. Schools of small fish moving through the canopy in silver pulses. It was one of the richest marine habitats on the planet. Not just alive, but architecturally alive. The kelp itself, the structure that made everything else possible. Along California's north coast, bull kelp canopy coverage fell by more than 95% in just over a decade. That number is worth sitting with. Not a gradual thinning, not a gradual decline, but an abrupt collapse in the aftermath of unusual ocean warming along the west coast. The cathedral is gone, and in its place, something that looks almost peaceful from a distance, until you understand what you're seeing. Swim off the edge of a good bed in the wrong stretch of coast, and the forest can just stop. The kelp thins, then vanishes, and what is left is rock-carpeted wall-to-wall in urchins, mostly purple urchins, packed shoulder to shoulder like a spiny purple pavement. That image, an entire seafloor reduced to a single creature, motionless, waiting, is the scale interrupt the numbers alone can't deliver. These are urchin barrens, stretches of seafloor grazed so completely that kelp cannot re-establish even when conditions briefly improve. Urchins can survive on extremely small amounts of food and are even able to shrink in size to reduce energy requirements, effectively locking the system in place. One urchin on bare rock is just an animal. Millions of them, holding every square foot of seafloor from the surface to the sand, is a different kind of silence entirely. The warming ocean did not act alone. A key urchin predator, the sunflower sea star, was lost to sea star wasting disease, leaving the kelp forests of Northern California effectively without any remaining urchin predators. Sea otters, the other major check on urchin populations, have been absent from the north coast since the 1800s. Remove the predator, warm the water enough to weaken the kelp, and the urchins do the rest. Purple sea urchin populations exploded across the region, in some areas increasing by thousands of %, overwhelming any chance of kelp recovery. The collapse was not one event. It was a sequence. Each step made the next one easier. Now, follow what the kelp's absence means upward through the food web, because this is where the coast's losses become visible above the waterline. The kelp's stipes and holdfasts give juvenile fish somewhere to hide from predators. Rockfish, kelp bass, sheephead, and countless invertebrates all key on that structure. Without it, the nursery disappears. Without the nursery, forage fish thin out. And without forage fish, sardines, anchovies, the small, oily species that transfer energy from plankton to everything larger. The Brandt's cormorants nesting on the Farallon Islands begin to feel the pressure in the most direct way possible. In how many chicks survive a season? Strong, upwelling currents once created rich feeding grounds for seabirds to feast on sardines, anchovies, squid, and krill. And the Farallon Islands, surrounded by sanctuary waters, host the largest breeding colony of seabirds in the continental United States. When the forage base thins, that entire colony, thousands of nesting pairs, must work harder for less, and the chicks are the first to bear the cost. The California current itself, the cold upwelling system that has driven this coastline's productivity for millennia, is measurably warmer than it was a generation ago. Grey whales arriving on their annual migration along this coast in recent seasons have been arriving thinner, their fat reserves depleted by a leaner journey through waters that no longer reliably produce the prey they depend on. Some have stranded on Ocean Beach, not from injury, but from exhaustion and hunger. A grey whale on the sand is not a mystery, it is a measurement. And then there is the quieter force, the one that doesn't announce itself in a single dramatic image. Ocean acidification. The Pacific is measurably more acidic than it was 30 years ago as it absorbs carbon dioxide from the atmosphere. Pteropods, tiny sea snails, no bigger than a grain of rice, that form the base of the open ocean food web, are dissolving in that water. Their shells thin, weaken, and in some cases fail to form properly at all. They are almost invisible individually, but they are the foundation that everything above them rests on, and the foundation is softening. But the sea is only half the story. Behind me, the bay holds its own reckoning. That grey whale stranded on Ocean Beach, exhausted, not injured. Which part of this collapse hits hardest for you? Losing the kelp forests or losing the predators that kept the whole system in check? Drop your answer in the comments below. Because out in the bay, a quieter unravelling is already underway. The bay holds its own reckoning, and the reckoning begins at the waterline. Stand at the edge of a San Francisco Bay tidal marsh at low tide, and what you see first is mud. Rich, dark, alive-smelling mud, held together by the roots of pickleweed and cordgrass growing so thick and low they look almost modest. But that modesty is deceptive. These marshes are among the most productive ecosystems on the continent. Carbon sinks, storm buffers, nurseries for Pacific herring, whose spawn coats the eelgrass in a white film every winter, and feeding grounds for the shorebirds moving through on the Pacific Flyway. The whole system is quietly extraordinary, and it is quietly drowning. Sea level in San Francisco Bay has been rising measurably for decades, and the marsh's only defense is its ability to accumulate sediment fast enough to keep pace with the water. In many places, it cannot. The lowest marsh edges are going under faster than the mud can build. Eelgrass beds, where herring have spawned for thousands of years, are shrinking as the water warms and loses clarity. The nursery is thinning at its foundation, and the species that depend on it are beginning to feel that thinning in ways that travel far up the food web. And then, there is the creature that connects the bay's ecology directly to the dinner tables of the city itself: the Dungeness crab. In the 2025 to 2026 season, domoic acid, a potent neurotoxin produced by algal blooms that thrive in warmer, nutrient-rich water, forced repeated delays and closures of the Dungeness crab fishery along the Northern California coast. State health agencies determined that crab in these waters carried unhealthy levels of the toxin in their meat. The recreational season was delayed at its November opening. The commercial season followed, shut down or constrained by trap reductions well into the new year. What the warming ocean does to ocean chemistry is abstract until the crab pots come up empty and the Dungeness disappears from the menu. Then it is very personal indeed. Move uphill now, away from the waterline and up onto the coastal bluffs where the wind comes off the Pacific in cold, damp sheets. San Francisco's fog, the marine layer that rolls through the Golden Gate each summer morning and keeps the coastal scrub alive through months of zero rainfall, is measurably less frequent than it was 2 decades ago. The fog is not a backdrop, it is a water source. Native lupine and coyote brush on these bluffs or draw moisture from it directly, surviving dry summers on what the air delivers. Less fog means drier soil. Drier soil means roots loosening their grip. And into that loosening, invasive ice plant advances, better suited to the warmer, drier conditions, spreading across the bluff faces in a dense mat that crowds out everything that evolved here. Scale that back. From the continental fog system, a marine layer stretching hundreds of miles offshore, down to a single lupine plant on a headland, its roots in soil that is drier than it has ever been in its lifetime. That is the scale at which climate change operates here. Enormous forces, intimate consequences. The fog rolling through the Golden Gate, the pelicans riding the thermals above Ocean Beach, the herring spawn whitening the eelgrass in January. These are not just ecological features. They are the texture of this city. They are what makes San Francisco feel like itself. The urchin barrens offshore, the drowning marsh edges, the thinning fog, the poisoned crab season. None of these are projections. They are already written. What is not yet written is how much of the rest follows. Marsh restoration programs are expanding in the bay. Kelp recovery efforts are underway. The choices being made now about emissions, about sediment management, about how aggressively the city and the region act. Those choices will determine whether the next generation of San Franciscans recognizes the place at all. The pelicans are still here. The lupine is still flowering on the headlands. The herring still come. The question is not whether we love this place. The question is whether we love it carefully enough and soon enough to keep it. Subscribe for more and watch the next one.